Hi, and welcome to a new section of our course. Have you ever spent hours looking for a particular commit in your repo that introduces a bug? I'm sure that the answer is yes. And in this section, we'll talk about one tool that is part of the Git toolkit that will help in this situation. This tool is called the git bisect, and we will start this section with an introduction about this tool. So we will learn how does it work and when we should use it. Then we will see this tool in action. I have a project with a bug and tons of commit, and we will use a git bisect to find the right commit when the bug was introduced. After that, we will do a step further. We will learn how we can write a script that make the usage of the git bisect super fast. Let's start with our first video. In this video, we will learn what git bisect is. Then we will talk about the algorithm that is behind this tool that is called the binary search. And then we will see how we can start bisect process. If you are a developer, you know that only one thing is always true. The code contains bugs. The first thing that I do when I get a bug report is to find out in which commit this bug was introduced. Because when you found that commit, then it's more easy to find the reason of the bug. The problem is that finding the right commit is not an easy task. So you can start, for example, testing the previous release, then the previous one, but then you have also all the commits that are between the releases that can maybe introduce the bug. So if, for example, it takes only 2 minutes to test one commit and you have 1024 commits in your repo, it gets like more than 34 hours to test all the commits. Luckily, there is a simple algorithm that is called the binary search that can really speed up this process. Let's assume that this list here is our list of commits. We only have 15 commits. The one with the skull here on the left is the broken commit, so it's the broken that we are looking for. What we know is that the latest commit is broken, right? It has a bug, so we can mark this commit as a red. Then what we can do, we can check out a really old commit and verify that the bug was not there. And if we found this commit where the bug was not present, then we mark this commit as a green. Now that we have one green commit and one red commit, we pick up the commit that is right in the middle of this list. We test this commit, and of course this commit can be okay or not okay. In our example, this commit is not okay. It contains the bug, so we mark this commit as a red. Now the clever part. If this commit is already broken, there is no need to test all the other most recent commits, so we can immediately mark them all as red. Now that half of the commits are red, we can focus our attention to the left part of this list, and we basically repeat again the same algorithm that we did before. We test the commit that is in the middle, we mark it red or green, depends, and focus on the remaining part of the algorithm. Test again. Now this is red, test again, this is green. So we basically did only 5 steps instead of 15, and we found which one was the first commit that introduced the bug. That, of course, in this list is the first red commit, that is the commit with the skull. If we consider our previous example with 1024 commits, instead of taking 34 hours, it will take only 20 minutes to find the right commit. Now let's open our terminal and see how we can really start a bisect process. I have here a repository that contains exactly 1024 commits. You can count the list of commits, for example, with a git log, and be sure that this log contains 1 line per commit. And then we pass the output of this command to the command wc-l. Exactly, this is the list. This is the count of the commits that we have. To start the process, we need to run a git bisect. Nothing really happened because we need to still to mark the first red and the first green commits that in the git bisect language are called bad and good. So we can mark the current commit as a bad with a git bisect bad. Then I will check out the first commit. The first commit I can find with the same command passing to tail. And I copy the SHA-1 of the first commit. I can check out this commit, and I can mark this commit as a good with a git bisect Good. Now we can see here that from the original 1024 commits, we still need to test 511 commits, and this will cost us roughly 9 steps.